We are on question number 15. So the diagram in the answer space shows the triangle ABC is mapped onto triangle A1, B1, C1 under a reflection in the line x is equal to 6. Draw triangle A1, B1, C1 on the diagram in the answer space below. So ladies and this is the diagram, and of course this is the triangle. So this is triangle ABC. You can see I've got 2, 3, I've got 4, 2, I've got 4, 4. And now they are saying the line of reflection according to the question is on 6. So this is what we call a mirror line. So if this is my mirror line, this is my mirror line on 6 where x is equal to 6. Where x is equal to 6 is my mirror line. So always an object to reflect, it maintains the angle of reflection is always at 90 degrees. For example, here, if you draw a straight line, it joins the mirror, it should create a 90 degrees with the mirror. Now, the distance between the object and the mirror should reflect inside the mirror also. Inside, meaning that, for example, if you look at B is going to, for me to, I'm at B. To reach the mirror, I should move 1, 2. So I'm on the mirror, again I go opposite side, 1, 2. So this will be my B1. It has reflected. For C also, it will move 1, 2. I'm on the mirror. So inside again, 1, 2. This is my C. So this is my C1. Next, I come to A. It will move how many steps? 1, 2, 3, 4. I'm on the mirror. Let's count. 1, 2, 3, 4. I'm here. This is my C, my A1. So this is my A1. So the reflection will be like this. So meaning that this is my reflection, and I've drawn the diagram which they've asked me to draw. Meaning that this is my triangle A1, B1, C1, and of course this is the object, that is the image. So that's how we do it. What did I say? I said when you are reflecting an object into a mirror, first of all you establish the mirror line. In this case our mirror line is x is equal to 6, and every object reflects at 90 degrees. So this one creates 90 degrees with the mirror. Even here it creates 90 degrees with the mirror. The distance from the object to the mirror should be reflected inside the mirror also. So for example, here there are 1, 2, even inside 1, 2, that is C1. So that's how it is reflected. So ladies and gentlemen, this is about transformation. You can't avoid transformation because you will meet it. So right now we have met transformation. So if you don't have any idea, we'll be stuck. Thank you. Next question. Okay, this is our B. Question 15B. Solution. This is the curve which we have been given. This is the curve which we have been given. And then before we find dy dx, I should make this part, the last part, to be also linear. So that it becomes like this. Y is equal to x minus 2x to the power 2. Of course, plus this x goes up, it will carry the negative. And that is the x to the power negative 3. From there now I can find dy dx. How do I find dy dx? From today onwards, you should understand that dy dx, the following should be noted. The following should be noted. Number 1, dy dx of a constant is always a 0. For example, dy over dx of 7, the answer is 0. That is number 1. Number 2, dy over dx of x, the answer is always 1. So that's how it is. Then another thing what we should understand about dy dx, if my function is y is equal to n to the power, of course, x to the power n, sorry, this is n and this is my x. So what do they mean by saying dy? It means dy dx simply means this n in x, then n minus 1. This is how we differentiate. So dy dx of any function is always you multiply the power with the coefficient a and then you subtract by 1. This is what we'll be doing here. So coming back to what we have said, dy dx of x is always 1, which I've already explained, fellow viewers. And then from there I will multiply this. 2 times 2, it will be negative 4. Now this should be reduced by 1, becomes 1. And this one, here there is a 1, negative 3 times 1, it will be negative 3, x. Now this negative minus 1, I will get negative 4. And it means I've differentiated. If you are not comfortable with this one, you can also write this one as dy dx. It is the same thing, equals to 1 minus, this will be 4x, and this one, it will go back. This is on top, becomes a 3 over x to the power 4. This is the same thing. So one was written like this and one was written this. All of them are correct. So this is how we differentiate dy dx. So fellow viewers, unless there are some comments, you can please comment, and you are free, please let's share this knowledge. Please, dy dx, there's nothing funny or there's something difficult. Dy dx of a constant is 0. For example, dy dx of 7 is 0. Dy dx of x is 1. And this is how, generally, this is how it goes when it comes to calculus. Initially, when I start teaching topics, I'll be emphasizing. This is under calculus. There are only 2 types of calculus. There is integration and the differential calculus. So this is what we call differential calculus, and this is dy dx. Thank you so much.